Hi, everyone, or Dzień dobry. I don't know. Yeah, there we go. uh, so I'm Natasha, as mentioned. I've been doing Swift since it came out, pretty much. So when it was announced at WWC, I went home and started studying instead of going to parties. And I think when I started doing Swift, I just kind of did it as an Objective-C developer and using the object-oriented patterns that we were already familiar with. But then last year at WWC, they announced something called protocol extensions. And on top of that, there was this amazing session, WWC session, called Protocol-Oriented Programming in Swift. If you haven't seen it yet, this is the talk to watch if you want to know what Swift is about and start thinking in Swift. And Dave Abrahams, he actually named himself a professor of blowing your mind. And if you're gonna name yourself that, you have to kind of deliver or fail miserably. And he actually delivered, like he blew everyone's mind. So again, if you haven't watched this, make sure to watch it. And in it, he says that Swift is a protocol-oriented language, unlike Objective-C, which is object-oriented. So it's something really different than what most of us are taught or used to for years of programming experience, potentially. And then he went on to do a demo, and he talked about drawables. And he used the protocol-oriented programming to kind of draw circles and rectangles and kind of all this drawing art things. But for me, in my daily job, I don't actually ever work with drawables. I don't really do games or like really fancy things. I just do mostly pretty boring applications with table views, and you click in and you see something. Maybe there's an animation here and there. So I knew that what he was saying was like amazing and mind-blowing. But it was hard for me to kind of go back to my everyday work and immediately start being like, okay, I know how to do protocol-oriented programming. And it took me a while personally to start, kind of changing my mindset from the object-oriented and Objective-C type of mindset to becoming more Swifty and to learn how to take advantage of protocol-oriented programming. So today I'm going to talk about practical protocol-oriented programming, or POP is the acronym. And I'm going to talk about like very easy day-to-day things that we as iOS developers do, and how we can make them better by using Swift and specifically protocols. And I'm going to discuss views, table view, view controllers, and the networking or backend layer. So I'm going to start with views. So let's say your product manager comes over and they say, hey, I want this image to shake. This is a very common animation in apps that have passwords or usernames, and then if the user enters the wrong password, it kind of shakes a little. So this is just a very simple request. So of course, I would go and do exactly what I would always do. Go on Stack Overflow. And of course, because this is such a common animation, someone has the code for actually how to do it, so I can pretty much copy and paste it, just make it more Swifty. In fact, I think someone answered, and one of the answers is how to do it in Swift. So if you want Stack Overflow points, basically go to all the popular answers and be like, here's how you do it in Swift. I think it works great. But then the problem is, of course, the value I add to this is I have to decide where do I put this in my app. So we're shaking a view. So this is pretty simple. I'm going to just subclass my image view, and I'm going to add a function called shake. And then copy over the code. So very simple, basic stuff. Now in my view controller, I have, when you tap the shake button, it's going to shake the view. I might modify the shake a little to make it move a little bit more or less. But otherwise, it's very simple stuff that we do every day. And at this point, I'm very happy, Project manager asked me, I went on Stack Overflow, I just subclassed a view. It took me like, maybe 10 minutes or less, total. I'm all done. But then the product manager comes back, and then she says, what if I actually want the button to also shake? I don't like that it's only shaking the view. I want something else. So you can relate to this. Maybe there's a password field and a username field, and they're different subclasses, and you want them both to shake. So this is something similar. You start off with one animation somewhere, and then you want to apply a similar thing somewhere else. So of course, I can go ahead and create a button, and I'm going to add, subclass it, and then add another shake function. And now in my view controller, I get my image view to shake, and I get my button to shake. So hopefully this gives you a warning sign, because we just duplicated code from a Stack Overflow. So, very likely we'll need to make changes to it. And now we have this code in 2 places, which is really bad, because when we do need to make changes, we have to remember that there's a random button that has the same function. So this is very bad, and we want to fix this. So if you're in Objective-C, this is what I did. I created a category, and in Swift, it's just called an extension. So you're extending UI view. So I'm going to take out the shake code, and I'm going to put it into an extension, extend my UI view and add that in there. So this is kind of like the Objective-C way of thinking, I think. And this is kind of what happens now. Like, my subclassed image view doesn't have a shake function, and my action button doesn't have a shake function, because it's all been put into a category. So all views have a shake function. So you can see right away that this is not readable, because looking at this, you have no idea that these views could shake. And shake is not something that's like very common for all views, so should it even be something that's put into a category? So you have like no idea that that's the intention here. And then the other problem with categories is, it becomes this really big Frankenstein monster. I've had that happen a lot in Objective-C, where I would start putting, hey, I'm just going to put a shake function in this extension. Great, now it's only one thing. Then the product managers come back and say, I also want it to dim, or I want some other view to dim. Okay, now I put this in there, and it becomes kind of this garbage extension where there's just like a ton of random functions, and it's impossible to even know what's in there. And then the worst is when it becomes too long, and then the person is like, oh, it needs to shake, and then they go and rewrite the function sometimes. So now there's like 2 of the same thing. So categories are, I think, useful in some ways, but in a lot of times just using it kind of as this like garbage, like, oh, let's just add another thing in that extension, that can become very unyieldy. In addition to being unreadable, and it's like becomes very hard to even know it's there. So we can solve this with protocols, because this is a talk about protocols. So instead of putting it into extensions, which is kind of the maybe like way you did in Objective-C, we're going to go ahead and create a protocol. And our protocol is going to call shakeable. And the shake function is going to be implemented in our protocol extension, which is this is the power that came, when protocol extensions were announced. And we can constrain it to only work for views. So this is a very inert protocol, because if any other non-view implements this, nothing will happen. It won't have the shake function accessible. Only views will be able to use this. So now immediately we can see the benefits. Each view has, it extends the shakeable protocol. So now, without seeing anything else of what this view does, just by looking at the class signature, I can already know right away that the intention for these views is to shake. It's not hidden. It's a very clear intention that that this view is meant to do this. And when you need to find the shake function, you just click into the shakeable protocol. You can easily see where it is. You can modify it, and it applies to all views that are shakeable. And the nice thing about this is you can now do the same thing for dimmable, right? If your product manager comes over and says, I not only want it to shake, I want it to dim, you just add a dimmable protocol. And now looking at this class signature, I know exactly the intention of this view. It's very, very readable without me doing anything. And the code is all in one nice place, and it's named nicely. And when the product manager comes and says, hey, I don't want it to shake anymore, some users got vertigo and because they were driving and shaking and it got crazy, you just delete that, and now that's all you have to do to refactor. So that's very nice, and it's very clear. So this is, now I can go have some Pop-Tarts, but yeah, this is one way to, by using protocols in views, you can have you just added a lot of readability, reusability, and maintainability of your code. It became very easy to use with different components added in, added out. This mix-in functionality makes everything very clear. So now let's move on. Yeah, so this is, if you want to read more on it, this is a really good article from Totem Training on, they actually do a dimmable protocol, and they do, a very nice animation with it, and they show you how to use this in a more sophisticated way. So go ahead and read this. Yeah, so now I'm going to move on to view controllers, and in this case, UI table view controllers, but this could be applied to other parts of UIKit. So let's say you have an app that's basically just food pictures, which is pretty much like Instagram. So food from around the world. There are, in fact, square donuts from Budapest. And I love pierogi here, so yeah, good job on the food. But yeah, so we have a basic, UI table or table view controller. This is just stuff we do every day as iOS developers. And we have this code that we reuse over and over again in our view.load. We have to register nibs. We have to register each cell. So now you have to it's too long. You can even do it in one line, but it becomes this really annoying thing where you have to instantiate the nib, and then you have to register it. And I personally use, it's a common convention to use the cell's name as the nib name and as the cell identifier. So that's a pretty common practice. And coming from Objective-C, this, I would use NSString from class to make it less stringy, and so I don't have to copy the same code, the same string value and have a spelling error. So we have this, in Swift you can just do string, so now I have the same 2 lines of code, but it's a little bit safer than strings, because then I can make it into a string from the class name. So this is nice, but if you see an intern or someone who hasn't done as much iOS development come on your team, they might be a little bit confused. They're just like, oh, why are you stringifying the cell? So it's not great, but it's a solution that we were kind of happy with in Objective-C because that's how things are. So luckily we're in Swift now, so we can make this better with protocols. So the first thing is to kind of automate some of this. Our reuse identifier is always the string version of the class. So now I can create a protocol extension that only applies to views, where you have a static variable reuse identifier that's returning the string version of the class. So already we kind of took that out. And we can now extend every single table view cell to conform to this protocol. So now without any other work, every single table view cell has this reuse identifier function that will return the name it's stringified version of this name, so you never have to worry about that part again. So now we can just improve it, and we can see already the readability benefits here, because when you do for cell with reuse identifier, you just do the cell's name reuse identifier. So now the intern is not confused why you're randomly stringifying the class name. And now we can do the same exact thing for nib names, because it follows the same pattern. We can create a nib loadable view protocol that has a nib name, static variable that basically stringifies its own name. So basically the same exact thing. And now, because for nibs, not every single cell is going to load from nib. So we don't want to extend the whole cell, but the cells that are being loaded from nib versus storyboards or just from code, you can extend them to become nib loadable views. So right away, for readability purposes, you can immediately look at the cell and know just by looking at the class signature that, hey, this cell is meant to be loaded from a nib. So already readability benefits here, and now just call nib name, and it's going to do the same thing for every single cell, and you don't have to worry about it moving forward. And again, we have the readability benefits when you're instantiating nib name. You're just saying nib name, and then when you're using the reuse identifier, you're using reuse identifier. So already, it's still very long, but it's already much better. But we can actually make it a lot better, and this is combining protocols and generic. Now we either have nib loadable, things that conform to nib loadable view, and ones that that conform to reuse view. So using generics, we can now extend table view, where we can register each cell that conforms to reusable view protocol and nib loadable view. And we can extract those 2 lines of code that we use over and over and over again, which is creating a nib, and the second one is registering the nib. We can extract those using generic because we know that, hey, whatever is using this is going to conform to reusable view. So we know it's going to have a reuse identifier variable, or anything that conforms to nib loadable view is going to be nib. It's going to have the nib name. So you don't even care, that this is a table view cell. Whatever you're passing in, you just know it's going to have those 2 things, a nib name and a reuse identifier. And just knowing that, you can extract those 2 lines of code and register the nib. So now we go from this, which we're going to use, multiple times in our code, over and over again, to this. It's very safe. You just say register, and we give it the cell type. So, it's very readable. It's not these 2 ugly lines of code where just like, what's going on? Except that we know what's going on because we've been used to it. We're used to using it over and over again. And, we can even, again, use the fact that these conform to protocols to also apply this to dequeuing the cells, because dequeuing cells also falls in the same pattern where we have to know the reuse identifier. So now we can extend our table view, and we can say that these are in Swift, there's optionals. So when you dequeue a cell, you have to have this ugly guard statement where if the cell doesn't exist, then like my program should crash, otherwise return the cell. So this is kind of ugly and annoying, and part of, it's kind of there from Objective-C and older code that we have to take care of. So we can actually abstract that code away because we know that our cell is going to have a reuse identifier, because all cells now conform to the reuse identifier protocol. And we dequeue the cell with this identifier for that index path. So now we go from basically these like ugly 3 lines of code to just this. So now every time you're dequeuing a cell, you don't have to deal with optionals. or just like typing it. You just say what type the cell is, and you're set to go. You can use the cell. There's no like if statements. There's no guards. It's a lot more simpler. It's how we want to be using it. And the cool thing is, because we're using generics, if you do have multiple cells, you just say, you're like, if this is at this index, it's this type of cell. If it's at that index, it's this other type of cell. It's basically how we want UIKit to be, or UIKit to be. So using Swift protocols and generics, you can add a lot of safety to the UIKit API. So this is code that we write every day, and we're kind of used to it, and we're okay with it because that's how we've always done it. But Swift and protocols can help us extract the kind of ugliness and the annoying parts of UIKit and hide them and make our code a lot more cleaner and safer and readable. So I didn't come up with this idea, unfortunately. I learned from the best. This was actually a blog post by Guye Gonzalez. It's very good, so you should read it. You can, of course, apply the same things to UI collection view, dequeuing the cell, reusable cell. Just have that protocol out there, and now in your project, you don't have to worry about it. So highly recommend reading this. And then the other one is I wrote up a blog post on my blog, Natasha the Robot, and it's about how to do the same thing with segue identifiers. So segue identifiers is another problem area because we have to use strings or some kind of enum pattern. It's kind of the ugly part of UIKit. We can extract that out and use protocols and make our segues a lot cleaner and safer. And this was taken actually from a WWDC talk on Swift architecture. So now moving on, we saw how to make views better, how to make view controllers better. How do we do kind of more backend networking layer? How do we make that better? So for networking purposes, this is a pattern that I commonly use. We have some kind of like API service. In this case, I have a food service. And I have a function to make a get API call. And unfortunately, API calls are asynchronous. So we can't use the normal kind of functional approach to our code. We can't say, get me food, and it'll get us an array of food, because it has to go to the API, get the array of food, parse it, and then return that information. So we have to use some kind of callback. In this case, I'm using a completion handler. And we can't really use like a throws because it's not asynchronous in Swift. So I like to use, this is a very common pattern, also from Swift, but originally I think from Haskell, where you're using a result type. And a result type is basically an enum. So when you get a response from their API, it can either be a success or failure. If it's a success, you also want to pass in the array of successful objects, which in this case would be food. If it's a failure, you want to pass in the error, and then your view controller will kind of handle that based on the success or error case. So this is something, a result enum, that you're going to use in every single service, every API call that you have. So we can abstract it and make it more generic. So, this is our food service, and it's going to have a completion handler. So when the API returns, it's going to have a result where it's going to put in an array of food and return nothing. And the way we would use it is in our view controller, we're going to have a function that says get food. And then when the result comes back, we're going to pass it in to the completion handler. And if it's successful and it returns us the array of food, we're going to assign it to our data source. And the data source will like reload the table view. So now we can actually load our table view and show the food. If it's a 404 or some kind of other error on the API end, we're going to show an error. So this is pretty popular pattern. But the problem here is that this is the most important function in our view controller, and it does a lot of things, and we want to make sure that it handles correctly. And the best way to do that is by testing it. So view controller tests are hard. And in this case, it's even harder because this is like a whole asynchronous thing. It goes to an API call. So how do you test this and make it better? So the first step is going to be, the first step is we have to be able to inject our own food service because we want to be able to change out how the food service behaves so it doesn't actually go to the API, and we can actually put in our own result. So now we can test if how the view controller handles a success result versus failure result. So the problem here is I have a food service that I'm instantiating here, but instead you want to pass that in and make it injectable. So now my get food, I'm going to pass in a food service, and then I'm going to do the food service get food. So that's good, and it's an improvement. Now immediately in my test, I have at least the first step. I can call get food from service, and I can inject my own food service that my test will have control over. But how do we make it better? So currently, the food service has a get function, but we actually want to, again, make sure in our test that the get function gets called, because maybe your food service has a post function and delete function. We want to make sure that our view controller calls the correct function in here. And we also want to, again, inject the result so then we can easily test how the view controller handles the success result versus the failure result. And the best way to do that is by doing a protocol. So this is the gettable protocol, and we're going to make it a little bit generic because right now we're using a food service, but maybe we have a dessert service. And the type of what the result passes in can be generic. So now we can already, just by taking this function out and putting it into a protocol and making it a little generic, we're already making this reusable, and we're setting a standard for all our services. So anytime there's a get method in any API service, we now have a consistency right away. So this is associated type. So this is the way to make protocols more generic. And you're just saying, it's going to use this result with, in our case, it's an array of food. So how does this, we took out a protocol, how does this change our food service? It doesn't. We just extend and say, hey, our food service is gettable, and now it still works the same exact way. So we added a lot of kind of more generic functionality, and as we will see, we added a functionality that'll make it easier to test. But really, the food service on the surface didn't really change. And the cool thing about associated types with protocols is that they're inferred. So as soon as I said result and I put the generic as the food array, it already infers that the associated type is an array of food, which is really nice. So how does this change our view controller? It changes, again, very little, just with method signature. We now have to, instead of passing in a food service, we're passing in something that conforms to the gettable protocol. So, and in our case, our food service is a gettable. It conforms to the gettable protocol, but now we've added the ability to make anything that conforms to the gettable protocol be able to be accepted. The other cool thing is we can specify that the type, the associated type, has to be an array of food. So we don't have to use a food service, we can use any gettable, anything that conforms to the gettable protocol. But if you have a dessert service and your type is a dessert, you can't just pass that in here. So you did generics, but with a little bit of a constraint, and we constrained that it has to, whatever the service is that's passed in, it has to have the food, array of food as the result. And that adds a lot of safety right away to our code. So this is the only change we made. We kind of changed it to be more generic looking. And now in our view.load, we can, again, call this method, pass in a food service, which conforms to the gettable protocol that has a food array, and we're good to go. So this is done. So now, how do we use this? And this is in our tests. Remember that for our test, to test the view controller, we want to know two things. One is that get is called versus some other function like post or delete. So we want to make sure get is called. And we also want to make sure that we want to have control over what we pass into the completion handler. So in Objective-C, you might have done this with subclassing, but you can't subclass structs. So this is how the power of protocols. I can now have a test version of my food service that I don't have to subclass. And I make sure that my completion handler, it does the result, it returns an array of food. So now the associated type is immediately inferred as an array of food. So these are the requirements these were the requirements for calling the getFood function. It has to be a gettable, which are fake food services. And it has to have an array of food as the associated type, which is the case here. In this case, I'm passing in a success result and an array of food as my result. But obviously, I usually have a function that says what I want my result to be. And now you can pass in the result that you want. You can do a failure result, and then you can test your view controller to make sure that it's handling the failure correctly as well. So this is your kind of fake in your tests. And now I can easily write my test. I have my fake food service, and I'm calling getFood in my view controller, and I'm injecting the fake service, not the actual one. So now like an actual API call is never made, and I have very fine control of what I'm testing and what I want to happen in my view controller. So I'm testing that the food service get was called, in fact. And then the second thing I'm testing is that the data source was assigned, and then it was assigned to the food array that I actually passed in. So now I have very nice testing capability just by taking out methods that were already there and putting them into the protocol. I've added uniformity to my code. Now all networking can have a gettable. You can imagine having deletable, postable, or updatable protocol. And when you look at that method signature for your service, you can immediately understand what functionality is there and what is missing. It's injectable. It's easy to test. And that those are the big things, especially when your view controller, its like biggest job is to make sure that the data is there. You can apply kind of a similar idea to storyboards and segues. So this is an article I wrote that if you want to follow up and see kind of a similar idea being applied. And I highly recommend, there's a talk by Alexis Gallagher called Protocols with Associated Types. So we've used associated types to make protocols a little bit more generic in this case. But unfortunately, a lot of times protocol with associated types don't work the way you want them to work, and it can get very frustrating. This talk kind of goes into details of why that is, and it's really relaxing for me to watch, especially when I'm like really mad that it's not doing what I want it to do. It's like very calmly explains it, so I highly recommend watching this talk. So today I hopefully showed you something you can relate to with protocol-oriented programming. For views, you can kind of make functionality of views more compartmentalized. For view controllers, you can take the kind of unsafe parts of UIKit and take those parts out and make your code a lot safer and more readable. And for networking, you can make it a lot more testable and uniform and modular. But I think one thing with protocols is I think at first it was hard for me to think of ways to use them. But as soon as I started kind of experimenting and like finally figuring out, everything looked like it could become a protocol. So, you know, the saying where if you have a hammer, everything is a nail. So it's kind of like that, right? Protocols are a tool, and as soon as you start using them, I mean, I personally think I probably overuse them because it's so exciting and new, and I want to know how can I use it. But it's just one of the tools in our toolkit, and I highly recommend experimenting with it. In fact, Rob Napier has an amazing talk at .Swift conference, which is Beyond Krusty, Real-World Protocols, where he takes something that's bad, makes it a lot better with protocols, but then at the end, he like deletes the 20 lines of code and replaces it with like a 4-line struct. So, you know, like we have different tools. We have enums, we have structs, we have protocols. And these are all new concepts for us coming from Objective-C. So experiment with all of them. Don't just stick to protocols. But and another thing is, you know, when you saw in my first example of a shakeable view, I first subclassed my view and added a shake function. And that was fine for that purpose, right? It's only one view. It needs a shake function. Subclassing and like adding that was not a big deal. But as soon as I started duplicating the code, that's where protocols came into play. And at that point, you do want to use that. So don't like immediately jump to protocols, but experiment with them and see where that level is. Finally, the last talk I highly recommend is also by Daniel Steinberg on blending culture. And it's a beautiful talk about how you combine protocol-oriented programming, functional programming, and object-oriented programming to make your code better. So again, protocols are an amazing tool, and we have, with protocol extension, we have so much power to do a lot of code difference in Swift and make it more readable. But we have also other knowledge from different disciplines, and it's cool to combine them. That's protocol-oriented programming with Swift, and I'm happy to answer any questions. Thank you.
That was a very good talk.
I'm
glad you mentioned about these practical advices, like how to use those protocols, and when you have a hammer, you see all the nails. That was one of my questions. On one of the first slides, you mentioned about some professor of blowing minds. That this professor blows your minds?
Yes.
Because this protocol thing that you was talking about blows my minds, and now I see all of the usages of protocols. So, okay, do you have any questions for her?
Hello, long-time subscriber and fan here. Thanks for a talk. So I got a question about the slide where you showed those fake food service. If you could go back, it would be easier even.
Okay.
So basically, you created there a fake property with get was called, and then you asserted if it's true or not. like one slide after. And I'm wondering if that's really necessary, since there you have the asserts that checks if, well, this get was actually called, because if it wouldn't, this data source count and this data source itself wouldn't be through those later assets.
Well,
My question is, what's the purpose of creating this fake get was called if the results can tell us if it was called or not?
Yeah, so one way to make the test pass that you just mentioned, so let's say it doesn't say get was called, the implementation of the function could be me assigning a random array of food. There's no guarantee that it went to the service. So in test-driven development, you would actually kind of write the test first and then the function, and the least possible you can do to make this test pass is just assign a random array of food, and now get never has to be called, and the test will succeed.
Hey,
Yep.
that's great talk as always. Actually, I wanted to mention that you want, for the gentleman in the back, you want the get was called test to fail for that reason, not for a different reason. So you're actually checking if it was called and not if returned, whatever. And I had a question for the exact same slide.
Okay,
What was data source that you were talking to? Is it you're just
when I'm passing in the food, it's just a static. It's like in my test, so I have a random array of food. That's just for tests.
But what was the data source property on your view controller? Was that, if you just go back, you will see it.
Yeah. The data source is an array of food.
Okay, but it's just a property on your view controller that you're using to store the items that you want to show.
Yes.
Ah, okay.
Yeah, because later on you'll want to know, hey, how many rows in the section? So you do data source dot count.
Okay, so instead
Yeah.
of just
It could
calling
be-
it
it's- it could
foods
be-
or whatever,
yeah,
you
it
just
could
call
be
it data
called-
source.
It could be food.
Okay.
Yeah,
All right, cool.
just more generic.
Any other questions?
I actually have a question about the same slide with the fake food service. So you used a Boolean variable to actually check whether the function was called or not. Is there a reason why you didn't do this using expectation?
What is that? The assert true?
No, actually the one where, with the fake service. Yeah.
This one? Okay.
Yeah. So why variable and not expectation?
I think the question was why you did use the variable, not expectation.
I don't know. I don't know. Maybe you can tell me more about the expectations.
Now? We can do this later.
Okay.
We can do this.
That's just how I do it.
There was one more question. Yeah, I suppose.
One detail, when you implemented reuse identifier as a protocol extension, you extended it with a where clause for UI view. Why not a UI table view there? So why not limit the scope?
Yeah, you could.
Okay,
Actually,
so
yeah. That's probably better.
Okay, I also wasn't expecting this answer. Okay, so we have a small gift for you.
Oh,
for
thank
your
you.
talk. It was a great pleasure to meeting you here and listening to your talk.
Thank you.